A neat thing about polar coordinates is that a point on a plane can be represented in multiple ways. So here we got r equals 3 and theta equals 7 pi over 4, which is 315 degrees, and that's illustrated right here. What if we're given r is negative 3 and theta equals 3 pi over 4? Well, we just direct ourselves at the angle 3 pi over 4, which should be 135 degrees, and instead of moving forward 3, we're going to move back 3 units because we're given a negative. And actually this point here and this point here are the same point, just represented in two different ways. So if r is greater than 0, then the point P is on the terminal side of theta, and if r is less than 0, then point P is on the terminal side of theta plus pi. So let me show you what I mean. So if r is positive here, then we're just going to have our angle theta, and here's our point P, and that would be r. So, however, if r is negative, instead of just looking at our angle theta and moving backwards like I did on the first board, we can actually think of it another way. We can take our angle theta and we can add pi to it. We can do that because if we go back in the opposite direction with our negative r value, it's the distance from this ray to this line segment. It's just halfway across the whole circle, and halfway around the whole circle is pi. So our whole angle is going to be theta plus pi. So here's a quick example. How else can we represent 3 pi over 3, which that's r and that's theta. It's a polar point we're given. So we've got 3 and pi over 3, and if you think about it, any point on the plane, if you bring it around 2 pi, it's just going to be the same point because 2 pi is a whole circle. So we can just add 2 pi to that, and it's going to be the same point, which is going to give us 7 pi over 3. Also, if we were to give negative 3, we can, if we have r is less than 0, remember to add pi, so pi over 3 plus pi, which is going to give us negative 3 and 4 pi over 3. Now, to generalize this, we have pi over 3 plus 2 pi. We can just do that as many times as we want. We can keep adding 2 pi and it'll be the same point every time. So really we're going to be adding even multiples of pi, and that's where we come to this. We have 3 and pi over 3 plus 2n pi, where n is just any integer. And we're doing the same thing over here. We've got negative 3, and since we can just add pi and then add 2 pi to get to that same point, and 2 pi again, so it's always going to be an odd multiple of pi. So an odd multiple can be represented by 2n plus 1. And that's what we have right here. So negative 3 and pi over 3 plus 2n plus 1 multiplied by pi. So down here, here's just a general rule to remember. We've got let P have coordinates r, theta, and any other polar coordinate of P must be in the form of r, theta plus 2n pi, or negative r, theta plus 2n plus 1 times pi.